My dear colleagues, time is running out. The Empire is intensifying its attacks against our bases, and we're having great difficulty rescuing the survivors. We must admit we are struggling to organize ourselves, which is why the High Council of the Resistance is asking us to develop an information system that will help us to assemble rescue fleets with the ships we have at our disposal. And I'll explain you right now what is the main feature we need to develop here. So assuming we have 5 survivors to rescue, our new product should search for the ships we have in our inventory named swappy. So swappy is an existing web service developed with REST, and here we'll take a particular look to the passengers' capacities of these starships, because we want to filter out the ships that cannot transport any passengers, such as here the X-Wing. And then, on the eligible starship, we will apply a very complex algorithm to assemble the rescue fleets. And that algorithm will be based on AI. It means it will have more than 3 if statements in the code, which is the official marketing definition, right? But I will try to popularize this complex algorithm for you. As you can see here, the Millennium Falcon has a 6-passenger capacity, which is clearly enough to transport the 5 survivors we have, so it will be the only ship taking part to this rescue fleet mission. So we don't have time to lose, and we need to choose right now the architecture for this new product. And I'm suggesting to apply this classic layered architecture with a controller layer, depending on service layer, depending on persistence layer. Who agree with that? Yeah, some people here didn't take a look at the title of the talk. That was a trap, just to see if any Empire spies were hiding among our ranks. Because we won't use that architecture in that case. Although it can be really helpful, it tends to age poorly with time, and I will explain you why. But first, I just would like to ask you one simple question. In that kind of architecture, where are you supposed to find the business logic? Service layer, yes. But I also heard something else. Everywhere. And why? Because this architecture has some flaws. It doesn't properly isolate one layer from the other, and with time, the business logic will leak into the controller and the persistence layer, and as a result, your data access object there may have some business logic, making it here difficult to write unit tests, as you may need to rely on an external database or RMs, so it means that here you need to write integration tests for that. And it also means that if you need to change database technology, moving from SQL to NoSQL, for example, you will have to rewrite that business logic. But even worse, the most wicked engineers of the Empire go as far as putting the business logic in the stored procedures, directly in the database. Can you imagine that nightmare? I can see people having some post-traumatic stress disorder symptoms, so you know what I mean. Don't do that. But the problem is not only related to the business logic, it's also the same thing for all technical concerns, because you might think that anything related to the database would be in the persistence layer, but since this is a simple cascading architecture, I'm pretty sure you already have seen people writing some SQL requests from the controller layer itself. But also, usually, in Spring Boot application, you will see that kind of thing. So here, I just pick up one random GitHub project with Spring Boot, and this is the service layer, and as you can see here, that exercise class is annotated with @table @entity from Hibernate. So from the service layer, we are shipping a SQL database. You can also see that some of the fields are annotated with @JSON property. So it means that here, that Jackson annotation helps us to tell the controller how to serialize this Java class from the service layer over the network in JSON. So we just coupled everything together, right? The controller, the service, and the persistence layer. So if you have to change your database technology from SQL to NoSQL, for example, something that is a document-based application like MongoDB, it's pretty likely that you may have to need to change your service layer, and that will have an impact on your controller. But the other problem is related to the fact that when we are using structuring frameworks such as Spring Boot, we tend to put it everywhere, even in places where they should not be. Because if you are coupling your business logic with your framework, you may have functional regression when you will upgrade to a new version that has breaking changes. Like back in the days, if you had that experience to move from Spring Boot 1.3 to 1.4, you know what I mean. The thing is that normal that changing the version of the framework can bring functional regression, since the business logic is only algorithm, right? It has nothing to do with Spring or something else. And it makes the business logic less portable, because keep in mind that one day, your backend will become legacy. And perhaps 15 years ago, you develop a backend using EGB because that was the main thing at that time. And let's say that backend is still working fine in production, so still bringing value to the users. But today, you would like to modernize the technical stack since EGB is no longer maintained. But will it be possible to take that working business logic from this EGB application and put it in Spring Boot? Any guess? No, it's not possible because it will be EGB shaped, right? So we can wonder if that's normal, right? And furthermore, because this is a cascading architecture, if you have any trouble in the persistence layer, like a compilation issue, you will have the service layer that will fall with it as well as the controller layer. So we have a chain of reaction of errors. So it means that with time, you will have too many coupling with that architecture because what is missing is isolation here. It will bring you a lot of fragility. So today, we'll see an alternative to the classic layered architecture, which is named the Hexagonal Architecture, who had been coined by Alistair Cockburn, that goes over all the problems I just mentioned. And you will see that this is also a pattern to manage software complexity and technical debt, but we'll see that a bit later. So in Hexagonal Architecture, we want to sanctify the business logic because this is the most important thing in your application. This is actually what brings value to the users and what pays your salary. So we don't want that business logic to be everywhere. So we take all this business logic and put it in a single place. That way it'll be easier to write tests that has only one responsibility, functional test. And that place, we'll call that the domain. And maybe now you have one question for me. Julian, what's the difference between that domain layer and that service layer we used to have? Can you see it? Do you have it? The name, obviously. No, in fact, there is more than that, because the service layer we used to have has two responsibilities. First, the business logic, I told that already, but also it has to orchestrate deeper technical layers of the application, such as the persistence or web clients, web service clients. And this is something we don't want in the Hexagonal architecture. We don't want the business logic to be dependent on the technical layers, because we want that business logic to last longer. So here we'll apply a little trick. Instead of having the domain depending on the persistence, we'll invert that dependency. So that way, this is a persistence that will depend on the domain. The domain, we'll call that also the hexagon for whatever reason. And even, I think, Alistair is not able to explain why, but it was the hype at that time to use a geometric shape for naming, architecture, but anyway. So in that domain here, you will have, that domain will depend on nothing inside itself. So that way you sanctify the business logic, right? So it means that in that domain, you won't have any framework. The framework will be for the outside, the infrastructure. Infrastructure means all technical layers. But you don't have to reinvent the wheel again, because here, you are able to use libraries, but only if these libraries won't require you to rewrite half of the domain if you want to get rid of them. So here you have a better management of software complexity, because inside the domain we have what we call the essential complexity. This is the reason for being of your application, the business logic, and outside we have the mandatory complexity, which is all the technical layers that are required to make that business logic happen. And keep in mind that if you mix all the things together, you're creating what we call accidental complexity that sometimes you call technical debt. It's mainly the same thing. So let's do a zoom and see how hexagonal architecture is working. So as you can see here, in the hexagon, there is two sub-layers, the API and the SPI, which belongs to the domain. So API stands for Application Programming Interfaces, and those are a set of interfaces that help the outside of the domain to interact with the domain. So basically, it's made for controllers to trigger the features of the domain. And the thing is, these interfaces are the contract of your features, which only depends on domain object. To avoid any contamination from technical object, technical types, from the left side of the hexagon. So it means that anything related to Spring Boot, Jackson, the representation of your REST resources will remain only in the controller. The domain will be agnostic from that. Then it will be easier if you need to change the way to interact with your application over the network. For example, adding here a RabbitMQ receiver needs to write only one module here that uses this interface without having to change the domain. But the domain will need some data, right? So that's why here it defines a set of applications which are called the service providing interfaces that help the domain to interact with the outside. And these interfaces only depend on domain object as well to avoid any possible contamination from the right side here of the hexagon. So the SQL client here implements that interface, and anything related to ORMs or Hibernate, Entity Manager, SQL requests, SQL-shaped classes will remain here in the SQL client. So then if you need to change database technology, you'd only have to create here a Mongo client, for example, that has to implement that interface without having to change the domain or the controller layer. So that architecture is also called ports and adapters, because these interfaces of the domain are the ports on which the technical layers can connect to adapt the outside technical world, REST and SQL, for example, into the inner world of the domain. But enough talking, let's do a little live code to see how all those things are working. Is that big enough? Yes? OK. So in Hexagonal Architecture, we will always start from the domain, the business logic, because this is the most important thing. Once you have created the business logic, you create then the controller and then the persistence and the other thing. And you iterate that way, feature by feature. So here, we are at the really beginning of the application. So that's why here, I only have one module, the domain. And as you can see, here, it only depends on JUnit. And as a J, I don't have any framework such as Spring Boot. So for now, the feature is not coded yet, but I have represented the model, the business model of the domain. And you can see here, I have a fleet, which is a record of starships. A starship is something that has a name as a string and a capacity as an integer. Remember the passenger capacity. So let's write now the feature. But you have to understand that today, Hexagonal architecture is not only an architecture style, this is also a development process, in which we will shape the hexagon using some acceptance tests. We write some functional tests using acceptance test-driven development. So that's why here I have a functional test that should assemble a fleet for 1,050 passengers. When I will call the feature, I should retrieve here a fleet. And I would like to make sure that all the ships of that fleet have enough capacity to transport all the passengers, and also that each of these ships has capacity, meaning more than 0. OK. So let's write the code then. I would like the feature look like this. Assemble a fleet for passengers given a number of passengers. OK, so assemble a fleet here does not exist. Let's create that. Here, I have to create that and give a type, assemble a fleet. And for now, I will initiate that to null. So assemble a fleet does not exist. I will create that. Oh, sorry. And IntelliJ is asking me if I want to create that as a class or an interface. What should I use? Interface, yes. Because this is the contract to interact with the domain. So I will put that in the production code. And in which subpart of the domain should I put it? Remember API, SPI? Talk louder, I can hear you. API, yes. But if you don't like the name API, you can use features instead. So now I have my API package with my contract assemble fleet, which is empty for now. We'll populate it using here the for passengers method. And as you can see, it only depends on domain objects, such as fleet here, or basic types of Java, that will avoid any possible contamination from outside of the hexagon. OK, so here, to be able to execute that business logic, obviously I need a concrete implementation of it. So let's do that. I will call that fleet assembler. So fleet assembler, we create that. Obviously, that time it should be a class, because this is a concrete implementation, and let's put that in the production code. So obviously, it has to comply with the assemble of fleet contract. So, OK, let's implement the missing method. And here, we need to implement that for passengers. So let's write some business logic. You can see I'm coding really fast. I don't need any AI there. So it's called snippet anyway. So in the business logic, there's two subparts. First, we will retrieve the starship from the inventory named swappy. And then there is the AI model that will select some starships to constitute a rescue fleet. So let's start with retrieving the starship from swappy. So if you remember, swappy is a web service. So it means that if I want to call swappy, I need to write HTTP requests, REST requests. But I cannot do it here because this is the domain. It's not related to business logic. And the thing is, if I change swappy for something else, it's pretty likely that we'll have to rewrite that REST consumption API, REST API consumption, sorry, but it has nothing to do with business logic, right? So the only thing I have to do here is to create an abstraction that will represent what is swappy, what is generally a starship inventory, and I would like it to have a starships method that will help me to retrieve all the starships at once. So starship inventory does not exist. That time we'll create that as a field here, because this is a production code. And let's give that a type, starship inventory. So it does not exist, so let's create that. Class or interface once again? Interface, yes, because it's a contract to interact with the outside of the domain. And in which part of the domain should I put it? SPI, you got it right. Well, you know everything about hexagonal architecture already. OK, so let's populate the contract here. As you can see, it will return starship from the domain to avoid any contamination from the right side of the hexagon. OK, so here I have to do a little trick to filter out the starship that doesn't have any capacity. And now you have the code you're all waiting for. So I will show you my AI model, but don't be too hard with yourself. It's normal if you don't understand that code. And you know what? Don't take a look at it. You should not take a look at it. It's, you didn't see it, right? OK, I lied. There's no if statement. This is not AI. But I have a while, right, which is even better. So in fact, it's just a naive implementation, taking one chip after the user. But it's not the main point of this talk, right? It's here more about the hexagonal architecture. OK, so the business logic is developed. But if I want to be able to execute that, I need here an instance of starship inventory. So I cannot create myself a starship inventory. Instantiate the real one, because that will be a swappy client. This is technical. That will be implemented in the technical layer. So what can we do here? Some dependency injection through the constructor. And we'll see later how it works. OK, so I have one problem here. It's because the functional tests require as well a starship inventory. So even in the test of the domain, you cannot rely on anything technical, because you want the domain and its related test, which is responsible to test the business logic, to be agnostic from the technical part. So it means that here, we will simulate what is swappy using a stub. To do so, I will inline one referential here of fake starships with little one and really big ones. And we simply pass that here as a Java lambda, and it should do the work. Now I should be able to run the test. And even though this is fake data, we don't care, because the aim here is to test the business logic, not the real integration with the swappy client, something we'll do later. And as you can see here, this is working fine, right? The test is green. So what we have done so far, we've created a functional test here that help us to shape the contract of the domain, which is assemble a fleet in the API. Assemble a fleet depends only on domain object to avoid any contamination from the left side. And this is implemented by the fleet assembler, which is the concrete implementation of the feature. This one needs to retrieve starship from the outside, but since it cannot call swappy directly, it defines its own interface here, starship inventory, that only depends on domain object as well. And to make sure we are able to test that business logic, we create a stub here. Okay, so the business logic is down, and now we would like to make sure it brings the value it's supposed to bring. So the next step is to create a controller to expose that business logic over the network. So let's proceed now. Okay, so I have prepared a bit the things again, just to avoid all the boilerplates. And as you can see now, I have one new Maven module infrastructure, in which I will put the controller, and you can see that now it depends on Spring Boot. Makes sense, because frameworks such as Spring Boot, they are made to help us to handle mandatory complexity. On the other side, on the domain, I have added one protection here using the Maven Enforcer plugin with the band dependency rules, the band dependency rules, yes. I'm saying I don't want any external dependency here. So if by mistake here I'm adding dependency to Spring Boot or the infrastructure, the Maven build will fail. So you don't have to be that drastic, right? It was just easier for the talk. You can do some fine-tuning here using Maven coordinates. If you don't like having multi-Maven modules projects, you can use packages instead and perform exactly the same kind of checks than the Maven Enforcer plugin with ArcUnit, if you know. But I won't be able to show you what is ArcUnit here. Now we need to implement the controller. But it's not because we are inside the infrastructure that I will not start with a test. I will do a little here integration test, driven development, to shape the REST API of my controller. And here, I'm expecting to be able to do a post on rescue fleets. And it should accept a JSON. The JSON in the request should have a number of passengers. For that particular test, I'm passing 5. And as a result, I should have an HTTP status 201 created. And in the response of, in the body of the HTTP response, I should have a JSON. In that JSON, here, I should have an ID which corresponds to the rescue fleet ID. That should not be empty, a list of starships. And for this particular test, it should have only one value here, which is the Millennium Falcon with a 6-passenger capacity. OK, so let's create now the controller. So I do a little request mapping on the URL rescued fleet. And here I have my post mapping. So this is the endpoint that will be called on the post. So what should I do here? I should just call the feature. So exactly the same way it has been defined in the test. The functional test. So assemble a fleet for passengers given a number of passengers. So that number of passengers, we will retrieve that from the request. Thanks to Spring Boot, I simply have to add this @request body annotation on that class, which will contain the number of passengers. So Spring will serialize for me that number of passengers in that request. I simply have to retrieve it from there. Assemble a fleet does not exist. OK, so let's create that once again as a field. And here, IntelliJ is asking me if I want to use the concrete implementation, fleet assembler, or assemble a fleet interface. So on that side, and only on that side, if you don't like having too many interfaces in your application, you can get rid of this interface. But I personally prefer to stay on the interface because it will help me to be able to test the controller in isolation by stubbing the domain without having to rely on external mocking frameworks such as Mockito. Because since I'm using functional interfaces, a simple Java node that will do the work. OK, so as you can see here, it's not compiling because the domain returns a fleet while the controller expects me to return a response entity of that fleet. So as you may know, response entity is a Spring representation of what is an HTTP response, in which you can set the headers, the HTTP status, and the HTTP response. So definitely it's not something I want to be inside the business logic. This is technical and related to Spring. So this is where the controller is taking his role of the adapter, because it has to adapt what is returning the domain into something which is technical, which is a response entity of that fleet. You are using here some Spring factories like created from response entity that will help me to bootstrap a 201 created HTTP status, and I'm simply passing fleet as the body, at the yes, the body of the response. But to be able to execute that controller, here, I need an instance of assemble a fleet. Okay, so let's do some dependency injection. As you can see, it won't work, because at is stating here IDE, we won't be able to auto-wire assemble a fleet because there is no beans of that type in the Spring context. So what do we do in that case? Usually, we go to the concrete implementation, which is the fleet assembler, and here, we put some annotations such as at component, for example, or at service. Oh, there's some license, it's a bit weird. But can I use it here? No, I can't, because fleet assembler belongs to the domain, and this annotation belongs to Spring. Otherwise, I will couple the domain with Spring. So what people do usually to fix that problem, they go to the infrastructure, and in one configuration, they do some bin factories. So they instantiate themselves the object of the domain, and they annotate that with @bin to make sure it will be registered in the Spring context. But I don't like this option neither. It's like doing half of the job of the dependency injection framework. So I rather like to still rely on annotations because I find it to be a better developer experience. But how can we do that, since these annotations are Spring dependent? I will show you a little trick that will help you to make sure that it will be Spring that will be aware about the domain and not the opposite. And that's quite easy to do. In the domain, you simply have to define your own annotations. Usually, I'm not doing that only for Spring. I'm using that as a living documentation. Here, for example, I have an annotation named the main service that comes from domain-driven design. If you don't know what is it, it's like a feature. And I will tag anything which is a feature in my domain with that. But here, I am adding one retention policy set to runtime. So it means that it will stay at runtime, so it will help Spring to detect that a class has been annotated with that annotation. So then I simply have to go to my fleet assembler and annotate that with my domain service. The next step is to make Spring aware about this annotation, and that's quite easy to do. In one configuration here, you simply have to add a component scan directive, and you tell Spring, scan for my custom annotation. Anything annotated with that annotation should be loaded in the Spring context. And now, if you're going back to the controller, the error disappeared, and even IntelliJ is able to know that that will be fleet assembler that will be injected inside the controller. And now, my domain is still agnostic from Spring. So if one day you have to move to Quarkus, you will be able to do so. Okay. Now the organizer will be mad at me, but anyway. Okay, so I never use Quarkus anyway. I'm a Spring guy, so. Okay, but still, if you want to execute that, you need an instance of Starship inventory. Here you have two options. You can create the swappy client in the infrastructure, or you can do what I will do now. I will simply stub it. And I will explain you why just after. So, a stub of Starship inventory, we've created one already, remember? It was in the functional test. So here, I used to have an inline referential that I was passing as a lambda, and now I've wrapped that in one class because it will be easier to reuse. So that class named Starship inventory stub, it's inside the domain and inside the production code. I will explain later why. And it implements the Starship inventory contract, and it will return all the inline referential with that Starships method. And this is basically something I would like to be used in my application at production. So it's exactly the same thing. You create your own custom annotation, like @stub here. You simply have to annotate that class with @stub, okay? And the next step, you know that already. You simply have to change the configuration to take that into account, like that. And now, you will see that the test of the controller should work, right? So let's do that, should be there. Let's cross fingers. Hope I didn't forget anything. Normal errors, but it's green. Everyone are normal errors, right? OK, so why did I put the stub in the production code? Because, in fact, this application now, I'm able to run it and deploy it in a pre-production environment. And this is a technique I used when I was working at Expedia. We were working on a rail booking system that's really in a bad shape, and we decided to recode it from scratch. But unfortunately, the mobile teams already have planned to integrate our APIs. So in order to not cause too many delays, we passed a deal with them, and we said, OK, we will rewrite that business logic. We'll expose that in a controller with fake data. We'll deploy that, and you will be able to start your development. And they were really happy about that because they were able to learn about the domain, learn about the workflows, and they were able to give us feedback without having to wait for us to integrate the real train inventory that took us 1.5 months for the full team. So with that, you will be more incremental, and you will build some kind of super wiremock of your application with real business logic, even though this is fake data. If you don't have that need of being more incremental, you don't have to put that stub in the production code. You can leave that in the test, just to show you that with Hexagonal Architecture, you can be more incremental. OK, so what we have seen so far. We've created an integration test to help to shape the controller REST API. And that controller is, in fact, using the domain exactly the same way the functional test was doing, by calling here the assemble of fleet contract. And we just moved the stub in the production code to be able to deploy this application for alpha testers or something like that. But as you know, we won't live long that way. We need to retrieve real data. So now it's time to create the swappy client. So I will show you what is swappy. Swappy is a real web service, totally public. This is a referential of anything about Star Wars. So this is swappy. And as you can see today, they have a certificate date invalid error. So I won't be able to show you the real swappy. But fortunately, it won't have any impact for the rest of the talk. So let's see how to integrate swappy in your application using Hexagonal Architecture. So let's do here one jump again, and now you will see that I have a new package named swappy. And once again, what I will do first, a test. You don't like tests, man? But why? Because it's really, you will see it's really fun. Here, I would like to when I will call the Starship method on swappy client, I should retrieve these starships. But remember, swappy is an existing web service. And as you may know, it's not a good practice to be dependent on an external web service in your CI/CD, because one day maybe they will be unstable, like an expiring certificate, and your test will fail continuously, right? But fortunately, here, I have a mock server, which is a best practice that will simulate swappy. So here, I'm simply reproducing the swappy API. That mock server should expect a get on the Starship method, on the swappy here base URL. It should return with success a JSON containing a swappy extraction I've made. So the swappy extraction here, I will show you because it's quite interesting. So this is that JSON. And one thing here you can notice is that swappy is paginated. Oh, I didn't expect that. OK, so we'll see how we'll deal with that. The other stuff is that it looks like that they have generic API because they name their Starship results, but anyway. Also, there is a lot of data here in the Starship. I don't care about all these things. I only need here the name and the capacity, which is named here passengers. But there is something quite interesting here. Can you see it? That passenger is a string. How annoying, right? Because I need to sum these values, right? So let's see how we'll deal with that. So here are the swappy clients. It belongs to the infrastructure layers. So here it's annotated with add component. This is totally valid, right? It can be dependent on Spring. It has to implement the Starship inventory contract. which means that it has to return all the ships at once. So it means that the domain has made a design choice. It doesn't care about swappy to be paginated. And it means that this is a swappy client that will have to deal with it. In classic layered architecture, when you have an external web service which is paginated, some people end up being accidentally paginated in their service layer and as well in their controller layer, right? Just because of the choice of the external partner, which doesn't make sense. Here, we will avoid that kind of design choice contamination with the hexagonal architecture because the pagination will be handled only locally. So here, I will initiate a list of Starship that will be empty. I'm initiating the next page URL to the first endpoint, Starships. And while this next page is not null, I will retrieve the Starship from swappy, and I will collect them and iterate to the next page, right, until there's no next page. OK, so retrieving the Starship from swappy, quite easy to do. It's simply a REST template, right? HTTP client, an abstraction of it. I'm doing a get on the next page URL, and I'm serializing it in a swappy response. So the swappy response here is a Java class which represents the JSON response of swappy, which belongs to the swappy package there. And I only map the data I need. So here I have a next as the string, the next page, and results, which is a list of swappy Starship. And a swappy Starship is something that has a name as a string and a passengers as a string. But remember, in the domain, we have capacity as an integer. So it means that, once again, the domain has made a choice. He wants that to be an integer because he wants to sum these values. Usually in classic layered architecture, sometimes that string will end up in your service layer, and the service layer will have to do all the conversion and so on. But it doesn't make sense, once again, because it's a choice of swappy. If I'm changing swappy to something else that use a big decimal, what should I change my service layer, right? This is not my choice. This is accidental complexity. This is the choice of the others. But once again, thanks to the hexagonal architecture, all the things will be made in the adaptation, meaning in the swappy client. So that's why here we have to do this conversion. So the conversion here aims to transform a swappy Starship into a Starship of the domain, taking the name of the swappy Starship and the passengers here that will pass as an integer. And that complexity will stay here. If you need to change for something returning a big decimal, you just have to change it in an adapter, not in the domain. OK, so now we should be able to run that test, right? But now you know me. I'm writing code that passes my test, right? So will it be green? No more errors? Oh, it's not working. Why? Because sometimes I'm passing NA at an integer. What the heck? What's going on? So you will see that, in fact, swappy sometimes, as a passenger's value, they return NA, and sometimes they return unknown. Looks like they have a really bad data consistency. But it's not only that. You will see that sometimes they have here, yes, 1,000 separators. So it looks like that API was more made to be consumed by front ends and not back ends, right? And this is really an example, right? I didn't craft it just for the purpose of that talk. So once again, this is a lot of complexity that usually you will have to deal in classic layer architecture in the service layer. Is that a string? OK. Is that some weird characters in it? OK, the domain had nothing to do about it. All that complexity will remain in the swappy client thanks to the hexagonal architecture. So here you simply have to do a filter. Sorry, what did I do? Yes, it's there, sorry. And I think, oh, it's not in the right place. It's there, OK. And that filter will filter all the Starship that doesn't have a valid passenger value. What means having a valid passenger value? It means it's not NA or unknown. OK. Then I need to get rid of the 1,000 separator. And my master just gave me a really nice way to do that, which is quite easy to do. He said that in that passengers, I simply have to replace all comma to an empty string. And it should do the work, right? So as you may have guessed, my master is ChatGPT. Please don't do that in production. I'm allowed because I'm a professional prompt engineer. You're not. OK. So here, now, if I'm going back to the test, hopefully, it should work that time. So let's cross fingers. OK. Normal errors, but this is green. Great. So now we can integrate with the swappy. I won't be able to show you because they are down today. So here we've created an integration test to shape our swappy client, mock server, and so on. But that swappy client has to comply with the contract of the domain Starship inventory, which depends on Starship of the domain. So all the weird choice of swappy will never contaminate the domain. It will remain here in that adapter, which represents the structure of swappy, the swappy Starship here, that client will have to convert into the Starship of the domain. And the thing is that it's not a simple conversion. This is also what we call an anti-corruption layer, because everything that enters the domain should always be valid. So it means that when you have some weird things like passengers at NA, the domain doesn't care about that Starship. So this is the aim here of the swappy client to filter out all the swappy Starship that cannot be mapped into the domain. So that's why it's called an anti-corruption layer. OK, so let's say we put that in production. This is working fine, but we discover, unfortunately, that the survivors, they have to leave behind them all the materials, because we didn't think about having enough cargo capacity in the starships. So we did a little evolution. I will show you then. Now, if I'm going back to, OK, thank you. It's there, I think, the Starship, yes. Now I have a cargo capacity as a big decimal. But there's something which is annoying me. I have both capacity and cargo capacity. This is confusing, right? OK, so let's rename that to passengers capacity. OK, let's do some refactoring here. So do you know why at the end of the talk I'm doing that kind of refactoring? Any idea? No? Because I can. No, not only. In fact, do you have any idea about the impact of that change? Any guess? No? I just broke my API consumers, the REST API consumers. And I will show you. If I'm going back to the test of the controller here, and I will execute that test, you will see it no longer passes. OK, so yeah, it fails. Why? Because that test expects me to return a capacity in the JSON, while now I'm returning a passenger's capacity. Why? Because if I'm going to the controller, you will see that it's because I'm serializing directly the domain object over the network, which is a common mistake in Hexagonal architecture. So here, by doing that, I just coupled my consumers with my representation of the domain. So it means that when I did that change, I broke the API. And also means that if I need to do some REST versioning or REST deprecation, where should I put it? In the domain. What the heck? It has nothing to do with business logic. In fact, here what was missing is a representation, a REST representation of what is a fleet. And that way, it will help us to be more decoupled. Yes, as you can see here, now I have a fleet resource. It belongs to, here, the controller package. And a fleet resource is something that has an ID and a list of Starship resource. A Starship resource is something that has a name, a capacity as an integer, remember the old field, and a new field here, passenger's capacity. I'm also adding a map of deprecation just to tell the consumer, hey, no longer use this one, use the passenger's capacity instead. Okay, it's not the best practice to do it that way, but just to show you that, in fact, the Starship resource can be different from the Starship of the domain. And what is interesting is that here we are mapping twice the passenger's capacity of the domain inside the capacity of the Starship resource for backward compatibility, and here in the new field. So then I can call all the consumers and say, you should no longer use that field. In 1 month or 2, it will be deprecated without having to break them, right? But on the domain, there is no mention of capacity anymore, right? And now you have a better decoupling. So in fact, don't overlook the creation of these resources here, because it will help you to decouple the consumer from the representation of your domain. If you have seen the talk I did here 2 years ago about how to write REST API, which is business-oriented and go over the CRUD paradigm, maybe you have seen that the shape of my resources has nothing to do with the shape of what is inside the domain, because the usage of hypermedia, right? Links and so on. I won't have time to explain you that, especially here. But keep in mind that here, you may have something which is dedicated for the REST API. I didn't do the persistence layer, but exactly the same thing. You might need to represent this starship, this fleet, in a way which is SQL-specific to be more performant and something like that, which is purely technical, and maybe those things, you don't want that to be inside the domain as well. Right. So there is a big picture here of the hexagonal architecture. Something I didn't show you is that I also have some tests at the application level that test everything all together. But this is a simple Spring Boot test, right? That simply goes doing some REST requests on the controller. And here is, I have a mock server as well, just to see that everything fit together. So my name is Julien Topsiu. I'm a technical coach and the CTO of Shodo, a consultancy company, specialized domain-driven software craftsmanship. You can scan that QR code if you want to have access to the code I show you today. You will also have some resources on hexagonal architecture. And thank you very much. If you have any question, don't hesitate to see me after the talk. Thank you.